I am Shreyas. I welcome you all to the podcast filmed by IEEE DSCE student chapter. Uh, Even I'm a member of IEEE DSCE student chapter. Along with me, my seniors, Mr. Puneet and Mr. Chirag, who are also members of IEEE PES student chapter of Dayanand Sagar College of Engineering, and also the students of IEEE department of the same college, are here to interact with Deepak Krishnan, Deputy Director at WRI India. He's been an IEEE PS member since he was doing his masters in IIT Delhi. He's also specialized in techno-commercial strategy, policy, and planning for generation, transmission, and distribution of energy. He's also a certified energy risk analysis. It's our pleasure to have you here and to converse with you, sir. Could you please introduce yourself and let us know more about yourself?
Sure. Thank you, Shreyas, Satish, Puneet, Chirag, for inviting me. My name is Deepak. I work with the energy program at World Resources Institute, India's offices. We are a think tank, and originally WRI was set up in US in 1982. In addition to US, we have offices in India, China, Indonesia, Europe, Africa, Brazil, and Colombia and Mexico. So what WRI as an institution works on is on multiple verticals like energy, climate, food, forests, and water, oceans, along with sustainable cities. And we also work on multiple cross-cutting areas like economics, governance, equity, and business. As I said, we are a think tank. We are research and data driven, and we also try to see where we can, put research into action. And for this, we work a lot with private sector, governments of various levels, national, state, municipal, and all that. So that's a brief about me.
It's a pleasure meeting you, sir. So we'll start with the podcast. So I request Puneet to start with the podcast.
Hello, sir.
Hi, Puneet.
Sir, can you please start by telling us a bit about your journey and how you became involved in the energy and utility sector?
Sure. So I did my bachelor's in electrical engineering, and subsequent to that, I got more interested in the power system space. So I then went on to do a master's in power systems engineering, and it's during that I kind of wanted to explore going beyond core technical aspects. So the doing the simulations of facts devices, looking at the power electronics or power system modeling, I felt that I also wanted to know about more practical applications of these rather than continue further into deeper R&D and all, which is of course important. But my interest at that time were looking more at how these things are getting applied. So it was at that time that management consulting firms like PwC, KPMG, and all, they have their own energy consulting practices where they do need technical people to support the business consulting assignments. So it was so that's how I entered into the space during the campus interviews. Spent about 8 years in the energy consulting or the management consulting side, but working more on energy projects, looking across the value chain from mining, generation, transmission, distribution. We also looked at a lot of regulatory efforts. And towards the end of my stint at the management consulting firms, I was also intrigued by the climate change space and the organizations that are working there, and that's how WRI came up in 2014. I am working now in their energy program. I started off by working on the commercial and industrial consumer side by trying to see what is driving their renewable energy adoption. How can we make sure that they take on more RE? And over the time, we have also started to work with municipal corporations on energy efficient buildings, state governments, discoms, and the energy transition conversation has also evolved over the last few years. It's getting more and more interdisciplinary. So it's an exciting space right now. Lot more to do with multiple varied targets that different governments and private sector are setting, and with a real threat of climate change also approaching at a very rapid space. So that's broadly where I'm working on and where the direction of work has led.
So it's really been a long journey for you in that sector. Sir, as a certified energy risk professional, could you explain the importance of risk analysis in the energy sector and how it's affected decision-making process?
Okay, so risks are there in all decisions, even if you take a and especially in energy sector where investments are very large. Small projects are fairly rare. It's only, for example, if you look at household solar, for instance, one can say in absolute terms that it is small. But even for even if you were to install in your own house, relative to the amount of income that a household would have, that investment is also fairly large, and therefore risks are there in all decisions, and especially when it comes to extraction of these resources, building infrastructure across large chunks of land, ensuring that commercial contracts are honored. There is also a social and political angle to energy decisions, because governments and politicians want energy to be affordably available to people. At the same time, there is the challenge of decarbonizing it. So risk is present in all decisions in the energy space. So the risk professional certification was more a way of understanding how the financial world also takes a look at this, because a lot of energy related decisions, particularly on the oil side, are market driven. Everything is not about I buy and pay for it. Sometimes there is bets placed on how much the price will turn out in the future, and a lot of it has a bearing on finally what will be the price that lands up at the people's household or factory premises. So therefore the understanding the aspects of risks is very important, because that will help us understand how to minimize those risks. And even if something is still there beyond and we cannot mitigate that, how do we protect ourselves against it? So that's where risk assessment becomes useful.
Sir, as you said that you mostly deal with big projects that come up in risk management. So if you could give us an example of a project that you handled in which and what aspects of risk managements were involved in it.
So back in the consulting days, we would have to do a lot of bid process assistance. For example, that was the time when transmission and distribution sectors across various states, and in fact even across various countries, were being privatized. So a lot of private sector people wanted to bid for the assets. So just to give you an example, Delhi's electricity sector used to be completely owned by the government. Now there are 3 private sector distribution companies, each of them holding 51% shares, and 49% is held by the government. Similarly, in Bombay, all of them are 100% private companies. During the time I spent in management consulting, Nigeria also opened up their electricity sector for private sector participation. They literally bid out almost all generating plants and distribution companies for people to come in and take over. So over here, when as a private person, I am going to invest money over the next, and these are very long investments. So in energy, 25 years is a normal investment span that people look at. You might pay off your loans in, say, 10 years, but your investment horizon is 25 years. You need to operate those assets, replace equipment, make sure that you do your billing and collection effectively. So understanding all possible risks, for example, understanding how consumer payments have been in the last 5 years. Has the utility manage to recover, if it has billed 100, how much it is able to recover, what are the reasons why it's not able to recover. Similarly, government incentives, how frequently they have been given, how frequently they have been taken away, are they really gaining benefits out of that? So a lot of such questions, would be there, and analyzing all this, protecting yourself against this, that is what will ultimately determine the final price that you would bid for an asset. Let's say how many millions of dollars somebody is going to pay to buy a generating plant. So understanding all these risks, presenting to the a client that these are risks we have identified, here is how we feel you can mitigate, and then they would come back saying fine, this is fine, but there are additional measures I have which I can use, so you can reduce the risk perception a little. So that's how risk analysis happens in these kind of projects. Similarly, if a government is wanting to announce a policy, for example, last year the Ministry of New and Renewable Energy announced the green hydrogen mission. So if a country has to launch a mission, it also needs to assess what are all the sectors that will get impacted, what will be the financial implications of announcing such a policy. Will it make my industrial base less competitive? Will it mean less exports for me? What if some other country is able to offer something else? So all these risk analysis would go into towards any such decision or final document that is going to be put out.
Sir, renewable energy is gaining momentum globally. Where do you see the most potential for growth in the renewable energy sector?
Okay, so theoretically, 100% RE is the target that everybody is going to aim for. For instance, there is a campaign called RE100, which is run by an organization called Climate Group, where a number of private sector companies, including in India, if you see Infosys, Tata Motors, I think Dalmia Cement, they have all committed to 100% renewable and running their operations on 100% renewable energy by a certain time period, 2025, 2030, whatever that time period may be. So that is theoretically the potential for RE to grow. But it is also what are all the technologies that can come in, and there is also a lot of untapped systems or potentials right now. For example, rooftop solar is not fully tapped in India. Offshore wind is just picking up. And then there is always a debate on whether hydro is considered as renewable by some country or not. Similarly, whether nuclear is considered renewable or not. So in the midst of all these debates, even if, let's say, for the sake of controversy, we say nuclear and hydro will avoid and focus only on wind, solar, and maybe biogas. Even within these sectors, there is still lots more to be done. For example, in wind, we have a lot of these old wind farms in spread across different states. Some of them were set up even as old as 1990s. Now, definitely their lifespan is over. Their efficiency is low. Better technology has come in. So replacing those assets with newer, larger turbines, which can help us generate more electricity, that is definitely one aspect of growth that we can look at. Solar panels themselves, their capacity utilization factor is max to max, it can go up to 20-26%. So how do we improve that efficiency? Similarly, offshore wind has in India particularly has not even started. We don't even have a single megawatt of offshore in our country. So how do we build that out? And at the same time also see that these large renewable energy projects are also built in such a way that they don't affect communities. They take care of environmental considerations. Like during the construction phase, let's say an offshore wind project, during construction phase, I should be careful not to destroy the coastal ecosystem. So even things like this are factors that the sector needs to consider, even though there are inherent growth opportunities within the sector itself. And yeah, as I mentioned earlier, 100% is the goal, but on its own, given the natural limitations, 100% won't come just like that. So would also need support of, say, storage technologies, which again, there are a wide variety. So this technology, commercial environment, social impact assessment. So within these constraints, there is definitely a lot more for the RE sector to do.
So, like as you said, there some countries don't consider nuclear and hydrogen as renewable energy. So, why is it so? And like, can you tell us more about the green hydrogen mission that has been initiated by the government?
Okay, so a small correction. I mentioned nuclear and hydro. Because hydrogen, definitely people are quite positive about it. So let me start with hydro. So the thing with hydro is that it doesn't emit carbon dioxide during generation. So some people look only at that perspective. They say, when you run a coal plant, there is carbon dioxide emission that comes out because of burning of the coal. That is not the case in hydro. Therefore, it is a clean resource, and water, people perceive that it is always going to be there, so it is renewable. But building of these large hydro plants actually submerges a lot of lands, and then the silting of the dams actually reduces the generation capacity over the years. There is also so that's the problem with large hydro for some sections of the population. So that debate is definitely there, but largely what I have been seeing is international organizations like International Energy Agency, International Renewable Energy Agency, and all classify even large hydro as renewable. India, till few years back, used to classify something called small hydro, which is below 25 megawatts, as renewables. But I think even now we are changing towards having large hydro considered as renewable energy sources. But that's more of a debate. Similar issues for nuclear. Again, while the nuclear plant is running, there is no carbon dioxide emission. But we have seen the dangers of a nuclear radiation. And there have been plant failures like Fukushima in Japan, which again was due to a tsunami. But so the question that some other people are asking is, can you guarantee that this nuclear plant will be 100% fail safe? Which I don't think anyone can give a absolutely foolproof guarantee. That is one aspect. Second, the mining of this uranium for production of nuclear energy. How dangerous is it for people working in those mines? Secondly, once the fuel is spent, how do you dispose of the balance? It can't just be left like that. It needs to be safely disposed of. What is the guarantee that there won't be leakages from it? This is all, and the reason why these debates are there is, if you compare it with the solar and wind projects, there is no immediate threat to life from those projects. So that is why all these debates are coming about. So and that will continue, because at the end of the day, these are infrastructure projects, and people's perception of safety and all that will definitely play a role. Now, about the hydrogen mission, I think green hydrogen, as you would also be aware, is becoming a regular feature of all conversations, and it is seen as a resource which can actually help decarbonize a lot of sectors like steel, for instance, where even right now a lot of coal is being used to reduce the iron ore and move the production of steel. So, for instance, hydrogen is seen as a significant technology that can come in there and help decarbonize the sector. So again, all countries are looking at this as an opportunity, just like in solar and battery, for creating manufacturing facilities, exporting the electrolyzer technology. In a similar vein, India has also started to look at what it can do to grow this industry within the country. So on the demand side, they are seeing which are all the sectors where hydrogen replacement needs to be done. So urea fertilizer is one big area where hydrogen is going to green hydrogen is going to play a role. In the oil and gas refining sector, again, hydrogen is playing a role. Similarly, you also have in steel. So these are sectors where the government is going to encourage adoption through pilot projects, through mandated procurement requirements, saying that maybe in year 2025, 1% of all the hydrogen you use should be green hydrogen. Going forward, that percentage increases, providing monetary support for pilot projects in different areas where right now costs are high, but through these pilot projects and incentives, the cost can be brought down. So that's broadly what the mission aims at, and ultimately the hope is that not only will these sectors adopt, but also technology manufacturers will come and set up their electrolyzer manufacturing facilities in India, use some of their output to meet domestic demand, and export whatever is possible, and help India become a leader in that space.
Sir, like you told, government is trying to get hydrogen into India, but then hydrogen fuel cells are already being used in Canada. So if I have to get the fuel cells in India, it costs a lot because of customs. If I have, is there any way to reduce the cost in fuel cells right now, as of now in the country?
So as immediately we wouldn't be able to bring down the cost, because even the Canadian manufacturer, for instance, why would, let's say you are the Canadian manufacturer, I am the Indian buyer. Why would you want to reduce your profits on a technology you have developed? That commercial contract we will have to respect, because, and truth be told, the costs are still high. They haven't come down, and customs is definitely an additional aspect, but in principle the main technology itself is not very cheap. Even globally adoption is not very significant, because costs have still not fallen to that extent. So that is where this green hydrogen mission from the government is coming in. They have identified a pot of money which they will you must have heard about this production linked incentive for solar and batteries, wherein if you set up manufacturing facilities, if you indigenize and bring in a lot of localization for a certain percentage of the manufacturing process, you will be eligible to get an incentive. So in a similar way, I think they will come out with incentives for green hydrogen electrolyzers and fuel cells, where people will be encouraged to set up larger volumes of these plants in India. And as long as they also involve local small and medium enterprises, they will get that incentive. And again, given that India's energy requirements are also so big, one is this incentive. Second, the very large volume that of business that you can get will help you do mass production and reduce the costs. And the third thing is, as different banks and financing agencies understand the market better, the costs of low cost loans, low cost investments will also come in, and that cost reduction will also pass on as lower costs.
Sir, as we are discussing about renewable energy, the major problem the India may face in the future is the recycling of the used batteries and the PV panels. How India is planning to tackle this issue,
right,
usually in the recycling of the batteries and PV panels?
Okay, so this has started to gain attention even at the central government level. Now, the only reason we have not seen anything at the very mass adoption level is that the volume of panels that need to come for recycling are still very small. It's still very early days as far as the technology is concerned. So there are a few startups who have set up pilot recycling plants. There is even a very large manufacturer called First Solar who has set up an in-house recycling facility. Now, their idea is that right now we'll experiment with the technology, identify what is the best means, how much recovery is possible out of what we are able to recycle. And right now, the only kind of panels that come in for recycling, let's say something which has a manufacturing defect, or if something is destroyed during a cyclone, thrown out and ripped. So those are the kind of panels that are coming in for recycling right now. We are not seeing, let's say, if you take the 2000 megawatts Pavagada solar park in Tumkur, for that full plant's solar cells or panels to come in for recycling, that is going to take at least another 10 to 15 more years, because that plant only came up 5-6 years back. So the hope is that by then we'll build up all this require a scale of manufacturing industries, build the supply chains that is required. Because one other question which is there is, fine, even if we set up all these recycling facilities, what is the guarantee that so much quantity of waste will come in every day, every month, to make the plant operational? We have seen that problem with even regular municipal waste processing facilities in the cities, where waste collection, segregation, getting it to the destination, that itself is a big a challenge. So that is the second thing that people are looking at. But what has started, so the government is definitely aware of this. For example, solar panels have now come in and they are recognized as a category which needs to be recycled in the electronic waste rules. So there is a end user obligation. For example, if I am the let's say I'm Longi Solar or Trina Solar who's manufacturing these panels, there is an obligation on me to tag those panels and take it back at the end of life to do some recycling. So that rule is definitely there. But now if you want to encourage a set of entrepreneurs, like if all of us decide to pull in some money and set up a recycling plant, with whom do we contract? How do we ensure the supply chains? That kind of conversations will still take time to come up. Also, another factor which is slowly coming in is that the issue of critical minerals. So lithium and multiple other minerals are now gaining importance in the new energy economy. So the question is, if I recycle my panels or wind turbine blades or any other device, can I extract these minerals from such recycling and therefore reduce the need to depend on new mining? So that is also coming in as a factor, and hopefully that will push the recycling technology development faster.
Yeah, like why I asked this question is because recently we found out that the lithium reserve in Jammu and Kashmir. So like India is more concerned about the extracting the lithium ore from the J&K to extract EV batteries. So this might be the major problem that like the government should be prepared for recycling the batteries.
No, definitely. And what we have in J&K, Rajasthan, and last year there was talk of lithium resource available in Mandya also. So we can't depend on always finding a new reserve suddenly to meet our needs. As much as possible, we should recycle, reduce the need for mining, because mining itself brings in other complications, like you have to acquire land for that, you have to displace people, the mining operation may affect the environment. So it doesn't, there are problems associated with mining also. Of course it is all the what you'll mine will ultimately get used in a clean technology, but that doesn't remove the fact that the mining is taking place.
As we are talking about recycling of batteries, the major chunk of batteries which are coming out are from the household, which are dry cells. You cannot much do with those dry cells because you cannot recharge it, or if you have to like just recycle even those batteries, you have to basically dismantle the whole thing and change the entire thing. That would basically mean you're making a new battery. So how can you reduce that waste?
Right. So you're right. So until now, whatever products we have, they have not been designed with recycling in mind. So even solar panels, for instance, if I take today's panels, they are the different layers are joined together with a kind of adhesive which doesn't permit easy separation of these. You have to literally crush the panels, and so the finally extracted value is very small, and that is the reason why recycling operations are also not very economical. So another understanding that is coming in within the manufacturing sector is that we also need to start manufacturing whatever equipment we make, keeping the end of life recycling also in mind. So that is another challenge that they are facing. What is a technology which I can ensure that it lasts for 25 years, and at the end of 25 years I can hand it over to somebody, or my own recycling operations will take it, and be able to be guaranteed, assured that they can extract so much quantity of different minerals. What and so that thinking has definitely started, and a lot of R&D is going on in terms of how to modularize these technologies, and make sure that at the end of life they can also be recycled properly. But yeah, with the current ones that are there, they haven't been designed keeping that in mind. Use and throwing it in a landfill has been the ultimate thinking, and that's why it's not easy to recycle the current ones.
Sir, how advancements in technologies are influencing the way the energy is generated and consumed?
Okay, so definitely a lot of change in the technology sphere has come in. For example, even 2013, 2014 also, for example, solar projects themselves were costing 11 to 12 rupees per unit. But now we are talking about 1.5 to 2 rupees per unit, especially for the large projects. We are also talking about rooftop scale projects of, say, 40 to 50,000 per kilowatt, batteries which can be accommodated with the rooftop solar, and so those are definitely incredible improvements in technology that we have seen. And at the same time, with the costs coming low, and with different regulatory mechanisms like net metering, where I can export whatever additional electricity I have into the grid, and earn some money. That is another technological innovation. Lots of states are also experimenting with blockchain pilots, especially for rooftop solar, so that people within a community can even trade the electricity amongst each other. So developments in these technologies itself, and similarly a home automation system on the demand side, which helps me monitor my consumption, schedule consumption depending on market prices. So the interface of the interaction of communications and changes in the electricity sector, they are proving to be a great boon as we move in this society.
Sir, as an energy and utility specialist, you have dealt with many various projects in the power system and in the energy and power and energy domain. So could you please describe a particular challenge in engineering problem that you have encountered in your projects and how you approach solving that problem?
Okay, so though I am an engineer, I haven't worked on a core engineering project. So as I said, after my master's, my focus was more on the commercial regulatory angles, and with using some of the technical skills. So more than a pure technology problem which I handled, for example, in my MTech, this is real life problems. Like one of the projects I worked on was devising a rollout plan for a distribution network. So that brings in a lot of challenges in terms of understanding how do you estimate load, on what basis are you going to say that such and such a substation will see so much increase in load. How do you account for extreme situations like some corner of some, let's say, residential project, somebody will want electricity connection, and you are duty bound to provide all that. So in such a scenario, how do you plan for network? If your network doesn't have capacity, can you afford to actually build a new transformer or build a new line just because it is one customer who is asking for it? Similarly, what are all the regulatory challenges that are going to be there? How much of your investment will be approved by the regulator? I mean, ideally, if a company wants, they can spend thousands of crores, provide the best in class meters, smart gear, and everything. But ultimately, all that will pass down as tariffs that we pay in our electricity bill every month. So how does one also balance the need to have the best of technology with costs that are going to be allowed, justify those costs to a regulatory commission, get approval for those costs? So this is where I found that a lot of engineering, economics, regulatory, legal issues, all of them come together, and real problems would actually come as a combination of all this. So how to handle it is definitely having a good set of colleagues to where the expertise is shared, and on your own also reading up as much as you can, trying to engage more with the people on ground who have experience of looking at all this, and also be willing to try out different sets of hypotheses. For example, developing a scenario one, seeing what is going to be the impact, developing a scenario two, what are going to be the impacts, and then discussing the pros and cons of different scenarios. So we are not going to have a sort of here is the solution, this will solve everything kind of approach. We need to and even top management and decision makers also rely on scenarios, and it's always a choice of the option that does the least damage and has the most benefit. So identifying that, being able to do that intellectual exercise of running those different scenarios, developing your model on which basis you will do these assessments, I think that was a very big learning for me early on in the career.
Thank you, sir. Thank you for answering that question. Over to you, Chirag.
So with your technical knowledge of power systems, what are some of the key advancements or trends you are observing in power generation and distribution?
So power generation, what I am seeing is that, of course, newer tech, lots of the technologies are known. For instance, there is nothing out of the blue that can come out and surprise us. For example, even though for now hydrogen is spoken of as the most cutting edge technology, which is the next best thing to happen, if we actually go back in history, hydrogen was there even during World War One time. There were hydrogen balloons which were used for transport, and the reason hydrogen did not pick up was because of its safety feature. We must all remember this hydrogen balloon called the Zeppelin, which caught fire and exploded. So it has been safety which has held back hydrogen. Similarly, windmills have been in use for ages. Especially in Holland, where it's a lot of, you'll find those old style windmills, and it's only now that technology advances in terms of capacity, fault ride through features that wind turbines can have. So these additional technologies which will help it interact with the grid, ensure that it doesn't become a standalone asset. Similarly, technologies that are going to help the generating assets as well as the consumers to interact in real time, identify, find out a price point that is suitable for all. Those are the kind of technologies which are going to drive adoption going forward. Energy efficiency is one other big area where I hope to see much more appliances becoming more and more efficient, so that we can save a lot of energy that is currently wasted. We are also on the distribution side, definitely fault detection is something which can definitely improve with the advancement of electric vehicles. Forecasting and prediction methodologies and tools which can help a utility understand what kind of vehicles are going to charge at what particular point in the distribution network. I think that is another technology which I have been observing, and people are also looking for example, based on past history, and if there is information of how two-wheelers are sold and spread across the city, can they form a predictive model saying that in this particular distribution transformer there is going to be charging of say 100 two-wheelers at 8 o'clock in the night. So that kind of predictive analytics is also something which is coming up in the sector.
So like smart grids are a topic of growing interest in this domain. So could you provide an overview of what smart grids are and their potential impact on energy landscape?
So smart grids, again, if you go back to the cliched definition, it can mean many different things. So For example, one way of looking at smart grid is how does it enable integration of renewables into the network. Another definition of smart grid might look at how does it help consumers interact with the network. A third would be how can we, for instance, use reactive compensation to enhance line capacity without the need to build new transmission and distribution lines. My take is that whatever be the technology, if ultimately the aim of the technology, if it helps bring in more greener technology, greener electricity or energy onto the grid, it helps keeps costs affordable and it helps reliability. So I look at these three metrics, whether it is on the generation side, whether it is on the transmission side, or on the distribution, or even on the consumer side. If that technology is helping do one of these three things, bringing in green technology, green energy, keeping the system more reliable, and keeping the cost more affordable. I think if any technology that does this and has an interface to the grid should classify as smart.
Like, what are your take on like smart grid being technology implemented in India and its future in our country, which has such a huge demand of power supply, and like how can this be improved or helped that it is applied very nicely?
So one immediate area where I see smart grid necessary is in the metering side of things. So right now we have a large chunk of electricity which is not metered, and even if something is metered and billed, collection efficiency is very poor. And that actually places a constraint on how much we know about who is consuming what, how much, and at what point of time. So therefore, in terms of say technologies on the smart grid side, smart meters are something which we definitely need in larger numbers. And then we also have prediction of renewable energy generation onto the grid. So if you see, the problem is that let's say I have 1,000 megawatts of wind, and then suddenly the wind doesn't blow, and you go from 1,000 to 0 in a matter of minutes. So in such a circumstance, we also need to have adequate forecasting technologies, and how they can help bring on that much generation onto the grid. So that's on the generation side. I spoke about smart metering, the reactive compensation of lines to prevent voltage collapses is another area that I significantly see. Equipment monitoring to do predictive and preventive maintenance is also a growing area and much necessary to be implemented. So a lot of things like this, and these are only the tip of the iceberg. I for example, haven't touched upon blockchain, that within industrial parks, within housing societies, how they are going to come up to enable people to do peer-to-peer trading. So lots of areas are there, but ultimately the test that we need to apply to all this is, are they making the supply more affordable? Are they making it more reliable? Are they bringing more green energy onto the grid? I think that's how we should not remain focused on which technology, but what technology, whether this technology helps us achieve these three goals.
Like you said, we need more smart meters in the market. For smart meters, we actually need more microcontrollers to actually use it. And in turn, the microcontrollers, to build them, we need more semiconductors. But then the price for semiconductors, as of now, it's rising. So, like, what do you think the trend would be in the near future?
Okay, so trend, see, right now it's not, it is increasing because a lot of geopolitics is also playing a role. Each country is trying to, get all the companies and suppliers within their own borders. India is also doing that through this production linked incentive for semiconductors. They're giving lots of money for people to come and do these chip assembly plants over here. In the near term, I would say prices will continue to be high. But if, for example, just speaking only of India, if we do manage to get that full supply chain within our country, right from the silica wafers to the circuit printing to the assembly modules, and then finally the meter manufacturing, then we can definitely expect large share manufacture and reduction of cost. But in the near term, I think prices will continue to be a little higher.
Sir, as you said that we should not focus on what technology, but instead the three aspects that it should fulfill. So like the people who are developing interest in this domain, like the freshers that have just came into college. So how should they channelize their interest apart from their college regular academics to grow in this domain and learn about it?
Right. So I think what they should focus on is understanding how the technology is going to be used. Because if you, for instance, go into the market and say that I have the best algorithm for, let's say, predicting, renewable energy generation, but in order to make that algorithm run and give 100% accurate results, if the costs are going to be humongous, so that the end tariff, which is currently, let's say, at 7 rupees, starts to go up to 10 rupees, then the technology will not see the end of the tunnel. So for example, as a fresher, what I would advise is, look at, definitely, yes, how the technology works, what it can do, cannot do, get all those things cleared first, because that is the fundamental. But then try to look for use case applications, work with local electricity companies, work with other private sector industries to try and see where all it can be applied, what are the current challenges that they're facing, try to understand that, and then try to see if your technology can fit in. Don't go saying that here is a technology, you see how to fit it into your operations. Understand their operations, see what the gaps are, and then see what technology is needed, what is, at what price point are they willing to adopt such a technology. So yeah, just moving out of the lab and prototypes, and also looking at what are the real challenges and how it can fit there, is what a student should look for.
Right. Thank you, sir. It was a great insight, sir.
Yeah.
Over to Shreyas.
Sir, it was great talking to you.
Same
I
here.
have some couple of questions. In the beginning, you told that Infosys and Tata is coming up with new renewable, going into RE 100%. So recently, Tata Power announced that they are going to renewable energy from thermal energy portfolio. What do you think about that decision of theirs?
So this is in line with what companies and countries are looking at. Ultimately, as I said, everybody wants to have a complete clean energy ecosystem, and moving away from coal and gas is something which is part of everyone's plans. And Tata Power is in line with that. They are also looking at moving all their operations to clean energy, and bringing in energy storage technologies to support that move. Not all companies will be able to do that in a very immediate time frame. It requires a lot of R&D backing, lot of financial backing, and Tatas are a large group. They can afford to do that. They also have experience of operating thermal and renewables, so they also understand the challenges in moving away completely. So I think even for them, it's going to be a step-by-step process. Definitely, it's not easy, but they are one of the groups who can do that.
Sir, also, when you're talking about renewable energies, re- every country is trying their own level best to do something so that they can convert themselves into renewable energies. So, like in the US, we can see Tesla coming up with setting up solar energy, rooftop solar panels to the houses. So, can such things be implemented in India also?
Yeah, so we have a lot of private sector companies working in the rooftop solar space in India also. Lots of residences have taken up solar. Industries are going about it in a big way, but that level of integrating solar into a building, that technology I don't think has come in yet, but it's only a matter of time, because ultimately even a company like Tesla, it will definitely need to look for markets outside if they want to become a global leader. So it will come at some point of time, but you never know if some Indian disruptor, maybe I'm speaking to some of the technology disruptors on this call, you with these one cannot predict how changes take place.
Like you said, prediction is really hard. Also, like when we go further on, nuclear fusion reaction also can be used as renewable energy sources. Recently, I read a paper that China has made an artificial sun. So artificial sun is basically them doing multiple chain reactions of nuclear fusion. So can that be implemented in the future and can replace a nuclear fission reactors in India?
Yeah, theoretically in future, yes, but right now, again, ensuring safety of that reactor and how big it needs to be, that is a major challenge. Secondly, right now these nuclear fusion reactions which are there in the lab are actually inefficient. For example, if I spend 100 units to get that nuclear fusion in place, the resultant fusion may be giving me only 50 or 60. It has to reach a stage where my input is minimal, but the output is more than that. Only then will it start to be much more, commercially and financially viable. Because right now, I need to spend much more energy than what I get out of it in order for that reactor to work. So that is the basic problem is anyway there, and then how large a reactor needs to be, how much I can, how much money is needed for that. So it's still a long, fusion is definitely a very long way off.
So like I have one question so that it can be a sort of advice for us. So like if I have to enter into a clean energy or renewable energy sector, what qualities or the thought process should I have to enter into the sector?
See, I think hard
Hello?
work and yeah, I can hear you. Can you hear me? Hello?
Yes, sir. Yes, sir. We
Yeah.
can hear.
Okay, okay. So I think
Yeah,
definitely,
yeah. You're audible.
yeah, okay. So definitely reading up, staying abreast of the latest technology, keeping track of what are all the latest developments in the space. I think that qualities of hard work, curiosity, and humility to learn. I think these three would be what I consider essential for any sector. It's not so much different here as well, and showing the requisite amount of interest and having the right aptitude. I think these are common skills which will be there across all sectors, and not much different over here as well.
Thank you for your great insights, sir. It was a pleasure talking to you.
Yeah, same here. Thank you for having me.
Over to you, Chirag.
Thank you for joining us, sir. Like it was pleasure talking to you.
Yeah, same here. Thank you for inviting me.
A lot of insights about all your journey and all what knowledge you could share us. Sir, could we share your LinkedIn so that we and the people of our college could connect to you on LinkedIn?
Yeah, I'll send it to Mr. Satish, and then he can share it with all of you. Would that be okay?
Yes, sir.
Yeah.
And thank you for all the participants for joining us. And yes, sir.
Yeah.
Thank you so much.
Thank you. Goodbye.